Students, we have completed the theory part of the chapter thermal expansion of solids, isn't it? And we have started discussing the numericals from this chapter. In this chapter, you can able to see that there are many sections. So we have completed discussing the numericals from your first section, that is coefficient of linear expansion. And we have started discussing the numericals from the coefficient of superficial expansion, isn't it? And we have discussed one or two sums from the superficial expansion. Now we will discuss more sums from this section. Okay, so I think you just check it out. Your sum number will be 6. Okay, I will just dictate the sum, don't worry, and I will explain also. A shop window, this is your sum number 6. Okay, a shop window is made of glass plate 2 meters by 2 meters, an allowance of 25 into 10 to the power minus 4 meter square being kept for the expansion. Okay, I will explain the sum, don't worry. Find the maximum variation of the temperature which this allowance anticipates. Okay, the coefficient of linear expansion of gases, the value is given per degrees. Okay, so what is being given in the sum? A window is there of glass plate. The dimension of the glass plate is also given. Okay, and a space is left, an allowance of so much being kept for expansion. Means a space has a space of dimension 25 into 10 to the power minus 4 meter square has been kept. For what reason? For expansion. Clear? Now you have to find out that you have to find out the maximum variation of temperature which this allowance anticipates. Okay, that means what temperature would be raised, okay, so that the glass window takes this space, okay, this space left for the expansion. So you have to find out that temperature. Understood? Now what is the value given? The coefficient of the linear expansion of the glass is given. So students, you just first tabulate the datas. The first value S1 value is what? See, the dimension is given in the first part of the question. Its value is 2 meters by 2 meters. That means 2 into 2 equals to 4. Isn't it? 4 meters square. Why? 2 meters into 2 meters, which will give you 4 meters square. Now, what you have to calculate? You just remember the formula. We need that S1 as well as we require the beta. Okay, now let's find out the value of beta. Beta's value is what? In the previous sum I used this expression also. Beta equals to means 2 alpha, isn't it? So 2 alpha means the coefficient of linear expansion of glass is given. So that into 2, isn't it? So 2 into 9 into 10 to the power 6, okay, given per degree C. Okay, now we have written the two datas. What are the next datas that we have to find out? Okay, you have to find out the maximum variation of temperature. Okay, so let's write the normal formula, usual formula that we write for the superficial expansion, that is your S2 minus S1, isn't it, equals to S1 into beta into what? Your T2 minus T1 part, isn't it? Because you just go back to the theory, your beta was equal to S2 minus S1 by S1 into T2 minus T1. Clear? So now what we have to find out? Since in the question it has been asked, find the maximum variation of temperature, means we have to find out this, isn't it? So what we will write next? S2 minus S1 by S1 into beta, we can write, isn't it? So now let's calculate. So S2 minus S1's value is what? Just calculate the value. See, in the question it has been given an allowance of 25 into 10 to the power minus 4 meters square being kept for expansion. Okay. So that means your change in the surface area will be that. Clear? A space has been provided. Okay. So for its expansion. That means for its expansion means for the expansion of the glass window. Is it clear? So that means this S2 minus S1's value will be that, isn't it? So I'm just writing the value 25 into 10 to the power, wait, 10 to the power minus 4. Okay. By, what was the S1's value? 4 I've written. Yes, 4. Into now beta part. Beta is this. That is 18 into 10 to the power minus 6. Okay. Okay. So now you calculate this. I think you will get approximately 34.7 degrees C. Okay. You will get near to this. Okay. So this, that is T2 minus T1's value is 34.7 degrees C. So this is the maximum variation. The answer statement also you can write, this is the maximum variation of temperature that can be anticipated. Okay. So just students, let's go through in a very short way what we did in this sum. I'm just explaining the question in a very short way, in a simpler way. A window is there with a window made of glass. Okay, the dimension is given and an allowance has been kept for its expansion, and you have to find out the maximum variation of temperature. So just put the formula. Okay, calculate the datas, you'll get the answer. It's very easy.